Question number 12 says integrate from 0 to pi x dx upon 1 plus sin x. How will we handle this? So there's an algebraic function at the top, but there's a trigonometric function as well at the bottom. And that x can be handled with this 1 plus sin x. How will we handle that? Okay, if you apply the king property, that is f of a plus b minus x1, this will convert to pi minus x. This will convert to sin pi minus x, which is sin x again. So once again, we'll get the same denominator. Yes, that is a useful property. We'll use that one. The property that we have been using is a to b f of x dx is equal to integral a to b f of a plus b minus x dx. This is what you have. Now this particular property, or it's a special case. This is P3 according to the NCERT, and there's a P4 as well, which is 0 to a and 0 to a f of a minus x will be there. It's a special case of this. But we'll live with this, right? Well, remember this one and we'll keep using this one. That's a special case which can be handled with this only. So I, which is integral from 0 to pi x dx upon 1 plus sin x. This is what you have. What else? I is also equal to integral 0 to pi, this is pi minus x, upon 1 plus sin pi minus x, which is again sin x dx. This is 1, this is 2. What we can do is simply add these two. This tells me, okay, in the left hand side you have 2i, which is equal to from 0 to pi, the integral of this x plus pi minus x, which is nothing but pi, upon 1 plus sin x dx over here. Now, what else? What else? After reaching this stage, there are two ways of moving it. One of the ways is that you reduce, since this is 0 to pi, this sin pi minus x will be nothing but sin x only, right? So, since the function is coming out to be same, you remember another property. This is P5 or P6, whatever you want to call it, P5 or P6, right? P5's special case is P6, so you can talk about P5 only. This is 0 to 2a f of x dx, which will be equal to 0 to a f x dx plus 0 to a f of 2a minus x dx, which simplifies to twice of 0 to a f of x dx for this particular case, since f of 2a minus x is same as f of x. What are we talking about? So complicated things? No, not at all complicated, but that is one of the approaches that you can use, maybe P5 on this. Okay. But then after that, what will you get? 0 to pi by 2, 1 plus sin x in the denominator. And if you use king again, that is this particular property, you'll get 1 plus cos x in the denominator. That will also not take you anywhere. You'll have to integrate this one. That's what I want to highlight, that after using properties, you have simplified up to this level, and then you have to think of integration. And remember, we had a similar kind of question, 1 upon 1 plus sin x, sometime back in the initial few exercises. How did we integrate that? This 2i is equal to pi times integral 0 to pi dx upon 1 plus sin x, or dx can be kept aside, 1 plus sin x in the denominator, right? That 1 plus sin x, we can multiply and divide with 1 minus sin x. What are we doing? We are multiplying with 1 minus sin x. In the denominator, you'll have 1 plus sin x, 1 minus sin x, which is 1 minus sin square x, that is cos square x dx. This is what you'll have in the denominator. Yes. So, this tells me I will be equal to pi by 2, integral from 0 to pi by 2, and this actually becomes 1 by cos square x is sec square x, which is easy to integrate. Minus sin x upon cos square x will be tan x into sec x, or sec x into tan x, which is again easy to integrate. Yes or no? Yes. And this will be pi by 2 is okay. Sec square x, the integral will be tan x. Sec x tan x, the integral will be sec x from 0 to pi. That's not pi by 2, 0 to pi is what we have over here. Yes. And what will that give me? This is pi by 2, which is okay. Tan pi is 0. Sec pi, this is 0 minus sec pi will be minus 1. So this will become plus 1 over here. Minus of tan 0, which is 0, minus sec 0, which is 1. This is what you'll get. So this is 1 plus 1, 2 into pi by 2, which will be pi. So that is my final answer for this particular question over here. Had we moved in another direction from here, had we moved on applying that P5 or P6, you would have obtained okay, 2 pi by 2 or pi would have been obtained over here, and this integral would be 0 to pi by 2. You get the same thing, integral limits will be 0 to pi by 2. And in that case, you will face one difficulty. What is that one difficulty? That substituting tan pi by 2 and sec pi by 2 will be difficult. Oh, tan pi by 2 is undefined, sec pi by 2 is also undefined. So what will we do in that case? Even if you move in that direction, what you will do is, tan pi by 2 minus sec pi by 2 is actually nothing but the limiting value of tan x minus sec x when x tends to pi by 2. So in that case, you will have to find the limit x tends to pi by 2 tan x minus sec x for this upper limit. That's what you'll be doing. For the lower limit, you can still have the 0 minus 1. That would be okay. And is that all? Yes, that's all in this particular question, number 12th, as you can see over here.